All right, so we've talked about graphing just from scratch from a table. We've talked about graphing from standard form. The next method we're going to talk about for graphing a line is slope-intercept form. And honestly, this one is probably the easiest, most common one you'll see. So before we talk about slope-intercept form, you know what an intercept is now, but we need to talk about what is slope. So slope is the rate of change of your line, and it really describes how steep or shallow your line is. The bigger the number, the more steep your line is. The smaller, especially the fractions, the more shallow your line is. Slope-intercept form is this y equals mx plus b, but we'll get back to that later. We're going to spend a few slides talking about slope on its own first. So if we look at finding slope from a graph, if we're looking at it visually, the line's already graphed, let's talk about what is slope, what does it look like, how do I find it? So slope is rise over run, which is really meaning that we're talking about how much it goes up or down and then how far it goes left or right. So if I look at these 2 points, this one is going up 2, and it's important that we're counting the boxes. We are not counting the lines. So we're going up 2 units, and then we're going over 1, 2, 3 units. So this one's slope is 2/3. We went up and right. Positive values are up and right. Negative values are down and left. So if I ever have to go down or left, that's a negative number. But here I went up and right. I could have gone right and up, but I always like to do up or down first since it ends up on the top. I think it's less confusing that way. Also, if you have more than 2 points on a line, you can use any 2 points and get the same answer. There's no rhyme or reason to which 2 you have to choose. So here they have 2 on your line. This one I'd have to go, I like to work from left to right also. You wouldn't have to. I could go up and left, but I'm going to go down and right. We'll get the same answer no matter which way we do it. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. So that's a -8 since we went down. Then this will be 1, 2, 3, 4, 5, it looks like. So my slope is -8/5. Improper fractions are what we want for slope. We don't want to change them into mixed numbers because it really is about counting down 8 and over 5. If I switch it into -1 3/5, I'd have to turn it back improper to count it out. So we leave them improper. If I had chosen to go up 8 and left 5, that would have just moved my negative to the bottom instead of the top, and that's the same answer. I like to work from left to right because I think that's just easiest in the grand scheme of things. I also like to go up or down before I go right or left, but really you'll get the same answer no matter what order you do things in, as long as you're careful and always putting the y on the top and the x on the bottom. Oh, also I want to point out to you, we read lines from left to right, just like we'd read a sentence from left to right. So this is going up from left to right, so it makes sense that it's positive. This is going down from left to right, so it should make sense that it's negative. Now let's talk about our special cases, our vertical and our horizontal lines. Vertical lines, this has a rise. It has a rise of 1, 2, 3, 4, 5 if we use their points, but it does not have a run. It's not going anywhere left or right. We are not allowed to divide by 0. That's not possible. So what we call this is undefined. So you'll see it as this symbol, or you can write it out as undefined. Vertical lines have undefined slope. Horizontal lines are very similar but the opposite. This does not have a rise, but it does have a run. So no rise at all. Does have a run of 5 if we're using the 2 points they put on there for us. 0 over 5 is still 0. So all horizontal lines have a slope of 0. All vertical lines have an undefined slope. Okay, so that's how we find it visually if there's already a graph. You could also be asked to find it by just having the 2 points, and you could plot these and count it out like we did in the last method, but I'm going to show you how to do it algebraically so that you have another method. And this is what we call the slope formula, where you have y minus y on the top and x minus x on the bottom. So I'm going to connect my y's on the top since they'll be on the top of my fraction, and it's always subtraction. So this will be 1 minus 7. which will give me negative 6. Then I'm going to connect my x's on the bottom, since they're on the bottom of my fraction, and I have negative 2 minus 5 is negative 7. So my slope is negative 6 over negative 7, but two negatives cancel out to be positive, so my final answer is positive 6/7. You can also change the order you subtract. I could do 7 minus 1 and 5 minus negative 2, as long as I'm consistent. So if I start with the left point on the top, I have to start with the left point on the bottom. If I start with the right point on the top, I have to start with the right point on the bottom. So here, I think it'll be easiest to go left to right. So I'm going to do 3 minus negative 5. And 1 minus negative 2. And remember, when you have these double negatives, you're subtracting a negative, you can add the opposite. So this will be 8 and 3. So 8/3. Again, improper fractions, we want them for slope. We do not want mixed numbers. If you come across a case where you could simplify, though, like 2/4 is the same as 1/2, you should simplify. But these do not simplify any farther, and they're totally okay being improper. All right, so now let's talk about actual slope-intercept form. And I kind of breezed past this, I think, but I've been using M for slope. We don't use S because S already stands for standard deviation when we're talking about mathematics. So they use M so that you don't get the two confused. There's no real specific reason they chose M. It's just that S was already taken. So M is our slope, and B is our y-intercept. And again, no real rhyme or reason why they chose B, but you don't want two y's in an equation. That would be confusing. So M stands for slope, B stands for y-intercept. Y-intercept, remember from our last section, is where your line touches the y-axis. So if we look at these two numbers in our equation, this is where it touches the y-axis, and then this is our slope. And remember, slope is rise over run. When you have a whole number, that's your number on top, and your number on bottom is a 1. Negative 2 over 1 is the same as negative 2. So when I'm graphing this, we're going to start at our y-intercept. We're going to start at positive 1 here. And then our slope is telling us to go down to right 1. So from this red point, I'm going to go down to right 1 to make another point. And I can do that as many times as I want. Now, I like to have at least 3 points. I think it gives you the most accurate line, especially if you're graphing these by hand and not on a computer. But you only have to have 2 points to make a straight line. And on Big Ideas and Delta Math, they only make you put 2 and then it connects it for you. So now let's take a look at a fraction example. That was a whole number example. This one is starting at negative 2. Make sure you include the sign that's in front. This was a positive 1. This example is a negative 2. So I'm starting at negative 2. And then it's always up or down on top, right or left on bottom. So this is up 3, right 2. So from my red point, I'm going up 3, right 2. And then you can do that as many times as you want. You could also reverse it and go down 3 and left 2 to continue on. Those would all be on your line. All right, so let's look at a couple examples where they're not, these are in slope-intercept form. So these are still in slope-intercept form, but I want to point out a couple things to you that always kind of throws students for a loop a little bit. So on this one, you might notice there's no number on the end. There's not one there. Whenever that happens, that means it's 0. Adding 0 does not change an equation, so you're starting in the middle when there is not a number on the end. This one's slope is 3/4, so we go up 3 and right 4. All right, the reason this one is tricky sometimes for students is there's no number in front of x that they can see. When there is not a number in front of x, it is a positive 1. 1x and x are the same thing. So when you're thinking of slope, this is really 1 over 1, up 1, right 1, up 1, right 1. If you have just a negative in front of x, it's a negative 1, where you go down 1 and right 1. So this one I will start at positive 5, Then I'll go up one, right one to make my other points. All right, now let's look at some that are not currently in slope-intercept form. So I'm going to first isolate y so that it's all by itself on one side of the equation, and then I'll graph it. So I'm, again, trying to isolate y here. So to move things away from it, I'm going to subtract 4x from both sides. And this is a positive 2, so it's plus 2. And then I'm going to divide everything by 2. You have to divide all three pieces. So this will be y equals negative 2x plus 1. And now I should be able to graph that. In fact, I did graph it. So I won't actually waste your time graphing the same equation. But that's how we would rearrange it. So let's take a look at this one. I'm sure we haven't graphed this one yet. So I'm going to start by subtracting x from both sides. So it's 2y equals negative x plus 10. And remember, this is the same as a negative 1. So if you want to put that 1 there, by all means, go for it. And then we'll divide everything by 2. So this is y equals negative 1/2 x plus 5. So we would start at 5. And then negative 1 means we're going to go down. So we're going to go down 1, right 2. Down 1, right 2. All right, so there's that line. So that's graphing from slope-intercept form. You do have a big ideas assignment today.